You cannot afford to miss this. The landscape of metabolic research is shifting rapidly, and understanding GLP-1 compounds for ocular health is becoming absolutely critical right now. Hello, fact finders. Lena Cruz here, your guide through the fascinating world of metabolic chemistry at Peptides.today. Today, we're cutting through the noise surrounding GLP-1 compounds and their profound implications for ophthalmic research. Conflicting headlines can be overwhelming, but the scientific truth offers far more clarity. We're going to explore how these intriguing molecules, crucial for glucose regulation, might influence ocular systems. Let's start by unraveling what these powerful compounds actually are. GLP-1 receptor agonists are synthetic compounds mimicking a natural hormone aiding glucose homeostasis research. Researchers explore their capacity to modulate insulin release in response to glucose fluctuations. Studies also investigate effects on gastric emptying rates and appetite-related signaling pathways. These compounds exhibit distinct pharmacological profiles compared to other glucose-modulating agents in labs. Consequently, they represent a vital area of inquiry in contemporary metabolic and ocular research. Optimized glucose regulation is consistently associated with retinal health observations in scientific studies. Research models with glucose dysregulation show increased susceptibility to various ocular pathologies. Thus, compounds stabilizing glucose levels are explored for potential long-term ocular protective effects. Ocular microvasculature exhibits high sensitivity to metabolic shifts within experimental systems. Sustained hyperglycemia can induce microvascular damage in research models over observational periods. Such damage is a recognized factor in the progression of various retinopathy observations and studies. Rigorous glucose regulation is a primary strategy for preserving ocular integrity in study populations. Therefore, understanding GLP-1's ocular effects is becoming an absolutely vital research focus. Scientists aim to elucidate if metabolic benefits translate directly to ocular systems. This research involves sophisticated imaging and biochemical analyses within controlled laboratory environments. We're constantly seeking new insights into these complex biological interactions to advance knowledge. This foundational understanding is crucial for all future investigations into peptide-based ocular research. That foundational science underscores why GLP-1 compounds are such a hot topic in research. But the story doesn't end there. Beyond their well-documented metabolic roles, what does the data suggest about direct ocular benefits, and, importantly, what emerging observations warrant closer scientific scrutiny? We'll dive into those complex layers next. And hey, if you're finding this deep dive valuable, make sure to follow me, Lena Cruz, for specialized insights, and Peptides.today for all the latest in peptide research news. Researchers hypothesize improved metabolic regulation could support long-term ocular well-being in study models. Reduced glucose concentrations are correlated with decreased inflammation and microvascular insult in experimental studies. Preliminary studies suggest GLP-1 compounds might exert direct neuro and vasoprotective effects. Some investigations propose potential applications in conditions like glaucoma, requiring further validation. This research is evolving. Larger-scale studies are diligently required for conclusive findings. While benefits are noted, researchers also investigate potential ocular observations in ongoing GLP-1 studies. Current evidence is largely observational, not establishing direct causation, prompting more experiments. Nevertheless, several ocular conditions remain subjects of ongoing investigation regarding GLP-1 interactions. A key research focus involves early retinopathy exacerbation with rapid glucose parameter optimization. This decades-known phenomenon may manifest with swift metabolic enhancements during observation periods. Similar effects are observed in studies involving insulin administration and certain bariatric interventions. Swift metabolic enhancements can transiently impact fragile retinal microvasculature during observation periods. This does not imply adverse effects. Long-term studies reveal improved ocular endpoints from robust glucose management. Routine ocular assessments are crucial for monitoring visual system integrity in research populations. Scientists aim to discern optimal research cohorts and identify groups requiring intensified observation. Novel investigations explore GLP-1 compound interactions with retinal tissues, the optic nerve, and microvascular networks. This ongoing research will continually elucidate their long-term effects on visual function and metabolic health. We've covered significant ground today, from GLP-1's foundational metabolic insights to the exciting and sometimes complex landscape of ocular research. This journey of discovery into how peptides influence our biological systems is continuous. Keep empowering yourself with data, not dogma. Make sure to follow Peptides.today and me, Lena Cruz, for more deep dives into cutting-edge research. Before we sign off, a quick legal disclaimer. This podcast is for informational purposes only and is not medical advice. All compounds discussed are for research use only and not for human consumption. Always consult a licensed healthcare provider for medical needs and treatment.